This is a Module 2B video describing alkene dihydroxylation. There are several reagents that will carry out this transformation, including potassium permanganate and ruthenium tetroxide. But the most useful of these catalysts, and the most selective of these catalysts, is osmium tetroxide. This transformation in a single step adds 2 oxygens to the alkene. But unlike the dihalogenation of alkenes with diatomic halogens, since this reaction occurs in one step, both oxygens add to the same face of the pi bond of the alkene. Osmium tetroxide historically has been used to stain unsaturated lipids in cell membranes for electron microscopy, as the osmate ester intermediates are dark-colored and nicely delineate cell membranes. But for synthetic applications in small molecules, this reaction is best carried out in a catalytic fashion because of the expense and the toxicity of osmium tetroxide. There are many oxidants that can be used for this transformation, but the most common ones are described here in methylmorpholine N oxide and potassium ferricyanide. I won't go through the mechanisms of the osmate ester hydrolysis, although this transformation is analogous to the hydrolysis of carboxylic esters. I also won't go through the mechanism of the oxidative turnover that is shown for organic and inorganic oxidants, but I simply present this to you for deep background. Scrolling further down the page, what's most important are the products that arise from this transformation. And from one equivalent of N-methylmorpholine oxide and one equivalent of an alkene, such as 1-methylcyclohexene, and a catalytic amount of osmium tetroxide in a mix of an organic solvent and some water to hydrolyze the osmate ester intermediate, we get 2 organic products. N-methylmorpholine, which can be separated by acid-base extraction, and a racemic mixture of the 1,2-diol, with the hydroxyl groups cis to each other. In the class meeting, we'll discuss, is the dihydroxylation diastereoselective? Is the dihydroxylation enantioselective? Is the dihydroxylation stereospecific? This ends the video on dihydroxylation of alkenes.